Well, that's right. And that is when we move on to hear from a very special guest amidst our presence. Well, ladies and gentlemen, he is the program scientist in the Planetary Science Division at NASA headquarters. Please welcome, amidst your big round of applause, our special guest, Dr. Henry Throop, as he's ready to address the gathering on this momentous occasion. A big round of applause, ladies and gentlemen.
Hey, Bowen, thank you. Thank you for having me here today. I have a couple of things to talk about projects we are doing with NASA in relating to chemistry and relating to the moles that we see in the world. So, I'm an astronomer. I'm not an astronaut. What I do is I use telescopes and I use computers and I use data to study the solar system and the planets and the universe that we can see around us. And as an astronomer, I get asked a lot of questions about the solar system and about the universe. But there's one question I get asked the most of all, and I'm going to tell you what that question is, because it kind of relates to what we're talking about today at National Mole Day. And that question involves mole. Oh, sorry, wrong mole. It doesn't involve that mole. I'll tell you how it involves it. That question is, are we alone in the universe? We have 7 billion people on Earth, and we have other animals and other plants and so forth on Earth. Is that the only life in the universe, or is there other life beyond the Earth? And another way of saying that is, do I think that aliens exist? Aliens is just another word for life in the universe outside of Earth. And here's my answer. My answer is, well, if you look at how many stars there are in the galaxy, there's about 100 billion stars. That's 10 to the 11th, one with 11 zeros after it. There's that many stars in the Milky Way galaxy. There's about 100 billion galaxies, so another 10 to the 11th different galaxies. The galaxies are the spiral-shaped clouds of stars. Each star in each of those galaxies throughout the universe has about 10 planets, maybe, going around it. So if you want to figure out how many planets there are in the whole universe, you can multiply those numbers together, all those numbers together, and you get 10 to the 23rd planets in the whole universe. It's this many planets, a 1 with 23 zeros after it, this many planets in the whole universe. That is such a huge number that I think it's almost for sure that we have life somewhere in the universe. That number, 10 to the 23rd, is almost the same as Avogadro's number, which is 6.02 times 10 to the 23rd. They're about different things. Avogadro's number is about how many molecules there are in a kilogram. This is about how many planets there are in the universe. But they're both huge numbers, even on the small scale and on the big scale. So when you're working with mathematics and chemistry, you deal with very big numbers and very small numbers. And this is one of the best examples of them. So I think there's life in the universe. However, have we ever found aliens in the universe? And the answer there is no. We keep looking. NASA has spent billions of dollars looking for life. Other people around the world have spent many, many decades looking for life, and no one has found anything. So no, we've never found life on Mars. We've never found bacteria on asteroids. We've never found radio signals that have been confirmed. Nothing. And so that's the big mystery, is if there's life in the universe, can we find it? Is it out there yet? And so this is one of the things which NASA and other people around the world are very interested in looking for. And so I'm going to talk about a couple of different places that NASA is looking to try to find life throughout the universe right now. And it used to be, if you go back hundreds of years, to the 1500s, used to be that we thought that the Earth was the center of the universe because we had Earth You had the planets around it, you had the sun going around the Earth, we thought, and then you had stars. But now things have changed a lot. We know that the Earth isn't the center of the universe, and we thought we were so special because we were the only thing. But now we know that we have the sun at the center of our solar system and the planets going around it, and there's all these planets in our solar system, and there's other solar systems and other galaxies around that. And so we're just we're just insignificant. The universe is vast beyond what the Earth and the solar system are. If we want to search for life through the universe, we need to know where to look. And the easiest definition of life that we can come up with is it's the most complex chemistry that you can think of. And the chemistry in life is much more complicated than the chemistry of anything else that we've ever come up with. It's much more complicated than that in microprocessors, or in ChatGPT, or in geophysics, or in artificial intelligence, or quantum physics, or the weather. All of these are really simple compared with the chemistry of life. So we're looking for the most complex life that you can imagine. And so how do you make the most complex life that you imagine? You need to do it through chemistry. And so chemistry is studying how the molecules and the atoms and the chains of molecules and groups of molecules get together to build a bigger and bigger, more complicated thing. Because things like DNA is super duper complicated. It's a long, long chain of molecules. And the way you do that is that a couple of things that you can do to make complex chemistry. You want to use really common ingredients, because if you're using ingredients which are hard to find, there's not very many of them, and you can't build life from them. So if you want to build life, let's build it out of things that are really simple and common, like hydrogen and oxygen and carbon and nitrogen. Because if you go outside and you take a scoop of anything outside, you're going to find a lot of these things. You're going to find a lot of hydrogen and oxygen and carbon and nitrogen. You want to do it in liquids, because there's some things like we have 3 phases of gas, right? Or 3 phases of matter. So you have gas, but there's not much chemistry that happens in gas because the molecules are so far apart. And there's not much chemistry that happens in the solids because everything's locked together and it doesn't move. But in liquids, that's why things rot. That's why things mold if you leave them out, because liquids, the chemistry can happen much more, and the molecules touch each other and they can move and react. And so that's why we love liquids for chemistry. And that's why we drink water, is because it keeps our chemistry going. And then you need to do it at the right temperature. If things are too hot, they dry out and you don't have any chemistry. If things are too cold, they freeze and you don't have any chemistry. So you put all these things together, and what we've concluded is that the search for life in the universe is kind of the same as the search for liquid water in the universe. So if we want to find life, let's start looking for liquid water. And there's a couple of places that NASA is searching to find liquid water throughout the universe, liquid water and possibly life. And I'm going to tell you briefly about 3 of these. First one is on Mars. The second one is on a moon of Jupiter called Europa. And the third one is on a moon of Saturn called Titan. And on Mars, we know Mars used to be wet. There's all these rivers that used to be on Mars. And we've sent up some Mars rovers. The Mars rovers are exploring Mars. There's 2 of them right now called Perseverance and Curiosity. They're driving around the surface of Mars. They're not looking for life, but they're looking for the history of water to see when Mars was wet, where its water went, whether there might be some water still left there, and what the water was like. Because we know there used to be water there, and we want to know what it might have done to the surface of Mars. And so we have chemistry experiments and chemistry labs on board these Mars rovers, and they pick up samples, and they grind the samples, and they heat up the samples, and they use their noses to smell the samples, and so they're testing all of the chemistry that they can do on the surface. And this is one of the Mars rovers right there. And then they're driving around, and so every day they drive to different places, and they look for chemistry, they look for interesting rocks, they pick up some interesting rocks, which we might be able to bring back later using the Mars sample return. And they see why Mars is dry now. Now there's a picture over here with Mars being filled with water. That's a fake picture. I put the water in there. That's what Mars used to look like, and then it's dried out now. And so when the Mars rovers are driving around, it's like they're 4 billion years ago, that crater used to be full of water. And now it's just full of the muck and all the stuff that fell to the bottom of the lake. Because if you go to a lake now, then all the good stuff, all the muck, falls to the bottom, and that's where you want to look for life. And so the Mars rovers are driving through this ancient lake to sniff it, to find the evidence of where there used to be life and what it was like. And we can see pictures from the surface. This is a picture from the surface of Mars, and it looks just like ripples, and you can see that it used to be mud, and then it dried out. And so this was on the edge of a lake, and it was wet, and then it dried out, and that's the sort of places where we're looking for interesting chemistry that might be related to life. So that's place number one. The second place is on Jupiter's moon called Europa. Jupiter's pretty cold because it's further from the sun, and Europa is made of ice, but if you look below the surface of Europa, it's kind of like going below the North Pole on the Earth. You look below the ice, and then there's warm water below it. And so this is Europa here. There's warm water, and maybe volcanoes spewing out some of that water from above. If there's warm water, and it's been that way for billions of years, then maybe there's life there. We don't know for sure, and that's because we haven't been there. So we have a spacecraft we're building. It's called the Europa Clipper mission. It's going to launch from the U.S. it's going to launch from NASA next October with the help of the European Space Agency. And it's going to orbit Jupiter for 4 years, and it's going to study and look for the chemistry and understand the ocean and perhaps look for life on Europa. Now there's a third place. This third place, the moon of Saturn, it's called Titan. Saturn is the only place in the solar system which has a lot of the chemistry and geology sort of like Earth. It's got mountains, it's got sand dunes, it's got lakes, it has oceans, it has craters, it has clouds, it has rain, it has everything that we think of on Earth, but we don't know if it has life or not. But what we do know is it has complex chemistry, and it's a fascinating place with so many of the things that we do see on Earth here. And so we're going to send something up to Titan to explore it. And what we're going to send up, believe it or not, is a drone. It's an octocopter, and so it's essentially an automated helicopter. It's going to fly through space on a rocket, and then the helicopter blades are going to come out when it's landing, and it's going to slowly lower to the ground. And then it's going to be able to fly around the surface of Titan for many months and explore the surface of Titan and look for its chemistry, explore its oceans, its seas, its mountains, its weather, and see if there might be anything related to life on the surface of Titan. So these are three places that NASA is looking for life using chemistry throughout the solar system. We're looking also well beyond. We're looking for life in other planetary systems out beyond, but those are much, much further away because we can't travel to the stars. We can just right now travel to the planets. So you have to use telescopes to look at the stars, very distant. We also study life on Earth to see where life came from. Okay, so that's what I want to talk about life. I want to give you just a couple of slides about how you can study this stuff yourself before I finish. I studied myself. I studied a lot of math. I studied a lot of physics, a lot of science, because that was what was really fun. You all are here. You're here at National MOLE Glory Day, and that's because I have a feeling that you really like doing chemistry and doing science and doing mathematics and doing engineering and things like that. So good for you for being here. That's step number one. To continue your studies, as I hope that you all do, you want to finish up, do as well as you can at your A-levels. Go to university, study what you're best at. Study if you're best at maths, if you're best at biology, if you're best at engineering, study that because that's going to be what you excel at the most. Then I got a master's degree, an MSc in astronomy and a PhD in astronomy. If you're interested, you can go abroad or stay in Sri Lanka. There's many options, both abroad and in Sri Lanka, to continue your studies. There are many universities in Europe and in the US. In fact, in many of these, if you go abroad to a university, they will give you a bursary so you can study science and so you can receive an MSc or a PhD paid for by the US or paid for by other countries. And so this is really fun because you get to be a scientist, work with other scientists, and earn a PhD at the same time. So there's so many opportunities to continue your education and learn to excel in this field that you love. There's so many jobs at NASA. There's so many different skills. Not everybody at NASA is a scientist. This is one of the science teams that I work on. This is the team that went to Pluto. We sent a spacecraft called New Horizons to Pluto. There's thousands of people that worked on this team. And there's scientists and there's engineers, but there's everybody else as well. There's astronomers, there's microbiologists, there's physicists, chemists, opticians, mathematics, genetics people, people studying medicine, environmental science, all sorts of different things, all sorts of different skills. Engineering, writing code, writing text, education, modeling, machining, documenting everything that does. So all of you have skills in these areas, and so there's opportunities to work in these fields for all of you. So I encourage you to continue your studies, dream high, and continue to be curious and explore the world around you. Thank you so much.